Hello everyone, welcome to Primer's Classroom. The purpose of this class is to help you to cover the entire syllabus. In this class, I'll be teaching chemistry, physics, and biology. And I'm going to try as much as possible to start from the beginning of the syllabus and help you to end the entire syllabus. So all you just have to do for me now is get a book ready, get your pen ready. Whenever I'm teaching, take a pause and write. When I give you definition, write. When I give you questions, solve them so that you can be carried alongside of each topic. So let's get started. The first class we're having today is on matter, separating techniques, and purity of substances. So we're going to be talking about the introduction to matter. We're going to look at the composition of matter. We're going to look at the states of matter. We're going to look at the differences between the three states of matter. Then we're going to look at change of states. Then from there, we'll move on to physical and chemical change. We'll now start talking about elements, compound, and mixtures. Then we'll focus more on mixtures, and now we can carry out separating techniques. Then after that, we'll look at the various separating techniques and purity of substances. And that will be the end of the class, and you're going to solve questions alongside. So let's get started. What is matter? That's right. So whenever you're talking about matter, matter is defined as anything that has mass or weight and can occupy space. That is matter. So as I am now, I am matter because I have weight and I'm occupying space. This chair I'm sitting on is also matter. Everything you have around you is matter. Anything you can touch is matter. You yourself that you're listening to this video, you are matter. You have blood flowing in you. You are breathing in air every time of your life. So all the things in the universe is what? Matter. So now, when you're talking about matter, what is really the composition of matter? The smallest parts that you can have that make up matter is the atom. So when you go from atom to element, element to compound, compound to mixtures, mixtures to matter. Are you getting that? So for example now, I might have drank water this morning. In the water, I have hydrogen and oxygen. That makes up the element. Then this water itself, it's a compound. Then the water I made, the food I've eaten, probably the glucose, the salts, all of them together make mixture. So the total composition that I have in me is what we call mass. So my entire thing that I have in me is what we call mass. So now I have mass. I'm occupying a particular space. Where I am sitting now, you cannot sit there. So that is why I am described as matter. So matter is anything that has mass and can occupy space. So the next thing is that what are the states of matter? Matter exists in three major states. The three states are solid, liquid, and gases. Now, when you're talking about the three states of matter, they have a lot of differences based on the particles that make up them. Now, if you look at solid, the particles in solid are well arranged, everything well tightly packed together. But the particles in liquid, they slide over one another, while the particles in gases are widely separated. So what am I saying? When you're now differentiating them, when you look at solid, solid has a particular shape. If I put water in a cup and I put it in a freezer, when I bring that water out, it will form the shape of that cup. And when I bring that out the ice from the cup and put it in a bowl, it will still take the shape of the cup. That means that solid have what we call a fixed shape. But how about liquid? Liquid always take the shape of their container. If I put water in the cup, it will take the shape of the cup. If I pour the water in a bowl, it will take the shape of the bowl. Your head is a solid, and that head has a particular shape. Let's imagine I take my head and put it on top of your head. You're not going to look like you again. You're going to look like me because my head has a particular shape. So solid usually have a fixed shape, while liquid take the shape of the container, but gases occupy every available spaces they have. Solid has a fixed volume, liquid has a fixed volume, but gases do not really have a fixed volume. Solid cannot be compressed, liquid cannot be compressed, but gases can be pressed, can be compressed. So that is what we're trying to talk about. And when you're talking about their rates of diffusion, the rate of movement, that is what we call entropy. So the rate of disorder is higher in gases compared to liquid and in solid. So let's move on to the next thing. Matter can be changed from one state to another. You can go from solid to liquid. You can go from liquid back to solid. You can go from solid to gas. You can go from gas back to liquid. So that is what we call change of state. So states of matter can be transformed, can be changed from one form to another. So what are the things involved in change of state? Whenever you are going from solid to liquid, we call it melting. When you are going from liquid to solid, we call it freezing. When you are going from solid directly to gas without passing through the liquid phase, we call it sublimation. I hope you're getting that. But when you're going back from gas back to solid, then we call it deposition. Now, when you are going from liquid to gas, we call it vaporization. When you are going from gas back to liquid, we call it condensation. So you need to know this change of state. They can ask you anytime. So the next thing to talk about that we deal with in chemistry is physical and chemical changes. Now you must have noticed something. Imagine I light a match. The match will burn to the end, and at the end of the day, I can't get that matchstick back. So that is called a chemical change. But imagine I bring out water from the freezer and I allow the water to defreeze. I can take it back to the freezer and the water will freeze again. So that is called a physical change. So what is a physical change? A physical change is a change that is associated with physical properties, while a chemical change is a change that is associated with chemical properties. So what am I saying? Whenever you are talking about physical and chemical changes, we must be able to differentiate them. Any change that is not reversible, that is called a chemical change. Or let me say that is not easily reversible, is called a chemical change. Any change that is easily reversible is called a physical change. For example, now, the match I lighted, when I burnt it, I couldn't take it back to give me the matchstick. That is a chemical change. The ice I brought out got to melt to water, but from water it went back to ice. That is called a physical change. So burning of substance is a chemical change. Rotting of fruits, rotting of leaves, you can't get the leaves back when it's rotting. So that is a chemical change. Now, when you drop a metal inside acid, the metal will displace hydrogen. So chemical reaction will take place, and that is a chemical change. When you have a metal and the metal rusts, rusting of iron is also what? A chemical change. Now, all these melting of ice, whenever you hear melting, condensation, all those change of states, they are physical changes. When you dissolve salt in water, it is also a physical change because you can recover the salt from the water. So what are the differences between physical and chemical changes? Physical changes, no new substances formed. In chemical changes, new substances are formed. In physical changes, the mixtures are easily reversible, while chemical changes are not easily reversible. So that is what physical and chemical changes is all about. So let's talk about elements, compound, and mixture. Elements is a substance that cannot be broken down into simpler units by ordinary chemical method. Although when you get to nuclear chemistry, you realize that you can break down some elements, some atoms here and there. But that's not what we want to talk about. So when you're talking about elements, we have 118 elements on the periodic table. So at least for the purpose of your exam, you need to know the first 30 elements. From hydrogen to zinc, you need to know them. So you need to know that every element has its own symbol. So learn about the 30 elements on the periodic table. We're still going to talk about them and how to write electronic configuration. So, but for now, what is a compound? A compound is a substance formed from the combination of two or more elements by chemical means. So whenever two elements come together, they form compound. While a mixture is a combination of two or more substances that are joined by physical means and can be separated by physical means. So let's differentiate between compound and mixtures. It is very important to know the differences between compounds and mixtures. So what is a compound? I already said a compound is formed from combination of elements. Mixture is formed from combination of compounds. A mixture is an impure substance. A compound and even an element is a pure substance. If I talk about a compound, compound is made up of probably sodium and chlorine, sodium chloride. So examples of compounds are water, table salts, which you call the common salt, that's sodium chloride. Glucose is a compound. Most of the substances you have around are compounds. But for mixtures, mixtures is a combination of different compounds. So whenever you're talking about mixture, mixture is an impure substance. So you need to know the differences. For compounds, you can represent them with chemical formula, probably sodium chloride. But you don't represent mixtures with chemical formulas. For example, the blood. What is the chemical composition for blood? I don't know. So there is no, so blood is a mixture. Vulcanizer solution is a mixture. Soil is a mixture. Flood water is a mixture. A lot of things are mixtures that you need to know. So try to look for more examples on mixtures and more examples on compound. Another thing you need to know is that mixtures vary in composition, but compounds has a constant composition. So mixtures vary in composition, but compound has a constant composition. So that is that about compounds and mixtures. So don't forget that your mixtures can either be homogeneous or heterogeneous. So whenever you're talking about mixture being homogeneous, it means that a mixture that exists in the same phase. For example, now air. Air is a mixture of gases, nitrogen, oxygen, carbon dioxide, and so on. But if you look at air, you can't really differentiate all of these gases. So that is why we said it can be homogeneous. It is also heterogeneous. If you look at flood water, you can definitely tell that something is wrong with this water. You see a lot of muddy nature, you see the water all mixed together. So that is a mixture that is what? Heterogeneous. So a mixture is said to be heterogeneous if it does not exist in the same phase. It is homogeneous when it exists in the same phase. So that is that about mixtures. So let's quickly talk about the separating techniques. So all of these things, when they mix together, let's say I mix salt and sugar. How do I separate salt and sugar from each other? So that is what separating techniques is all about. So I can mix two things together, for example, kerosene and water. If I mix kerosene and water, how do I separate them into their different components? So that is what separating techniques focus on. So we're going to quickly look at the types of separating techniques, the principles used in the separating techniques, and how separating techniques is carried out. So for example, number one is filtration. You carry out filtration when you are trying to separate insoluble solid from its solution or from its mixture. So you have insoluble solid in liquid and you want to separate it. You can use filtration. Just pour it on the filter paper. The solid obtained is called the residue, while the liquid that passed through is called the filtrate. So you can use that to separate any solid that will not dissolve in a liquid. So what is the principle you think that is based upon? The principle is solubility. So the solid should not dissolve in the liquid. So another type of separating technique is decantation. Decantation is also like filtration, but in this case, you're not using funnel. You're just going to pour it out. So you have the solid settled down in the liquid. Then you pour the liquid off. So many of our Nigerian guys, you must have done that to Gary before. So the next type of separating techniques is what we call separating funnel. You can use separating funnel to separate two immiscible liquids. So when you have immiscible liquids, the immiscible liquids form layer, for example, kerosene and water. They form layer on top of each other. Then you can drain off the one that is denser while you leave the one that is less dense at the top. So what we use in separating two immiscible liquid is separating funnel. And the principle we use is based on which one can go down, which one can stay at the top. So that is what? Density. So another type of separating techniques is distillation. We have two types of distillation: simple distillation and fractional distillation. So you use distillation to separate liquids that are miscible, liquid that will mix together. For example, if I have alcohol and water, when they mix together, the alcohol will mix with the water. I won't be able to tell the difference. So in order to separate the alcohol from the water, I carry out what we call simple distillation. But whenever you now realize that the boiling point for the liquid is very, very close, the principle you use in distillation is boiling point, in case they ask you. So whenever you now realize that the boiling point is very close, you use what we call fractional distillation. So fractional distillation is used to separate two or more miscible liquids of close boiling point. So what is the principle used in distillation? It is boiling point. So the next one to look at is what we call crystallization. You use crystallization to separate solids of different solubilities. So you have solids in liquid, but these solids are soluble in the liquid, but at a particular temperature, they become probably insoluble. So you can separate them from the liquid. So that is what we call crystallization. So most solids that can form crystals, like sugars and all, you can separate them from their mixtures by what we call crystallization. So we have two types of crystallization. If the solubility temperature is very wide, then you use what we call simple crystallization. If the solubility temperature is very close, then you use what we call fractional crystallization. So what is the principle for crystallization? Solubility. I hope that is taken. So another separating technique we have is sieving. Sieving is used to separate solids of different sizes. You must have seen those women that used to do garri like this. So they are trying to remove all the fine particles of the garri below the mesh, while they allow the solid to remain at the bigger particles to remain at the top. So whenever you are using sieving, you are using it to separate solids of different sizes. So that is what you use sieving for. So the last separating technique I'll quickly talk about is chromatography. So when you're talking about chromatography, just know whenever you hear that you want to separate things of color, ink, blood components, plant pigments, or so, then you're using what we call chromatography. There are different types of chromatography that will be done in a separate video entirely. So we have three types of chromatography. One is what? Paper chromatography, thin layer chromatography, and column chromatography. There is a calculation we do on chromatography. I'll be doing that probably during some other classes. So when you're talking about chromatography, it helps you to separate colors, pigments, and all of those things. So now, what is the principle chromatography is based upon? We have two aspects of chromatography. We have a stationary phase, and we have what we call a mobile phase. So the mobile phase can be liquid, can be gases. The stationary phase can be paper, can be gel, can be anything. So there are two major parts we have for chromatography: the stationary phase and the mobile phase. So the mobile phase will carry the solutes that you want to separate over the stationary phase. While the solute is moving over the stationary phase, they are selectively separated. They are adsorbed. For example, imagine I have red oil on water, then I pour the water on a foam. That means that the water will be absorbed by the foam will absorb the water, but the red oil will remain on the foam. So that is the principle of chromatography. So if you look at chromatography, then that one that is collecting the substances on the surface is called the adsorbent. So adsorbent collects it. So that oil is collected on the surface of the foam. The water carries the oil. So that water is seen as the mobile phase. The oil itself on the foam is seen as the solute, while the foam itself is seen as the stationary phase. So if they ask you that what is the principle of chromatography, is based on the rate of migration of a mobile phase over what? A stationary phase. So that is chromatography. So the last part to deal with is what we call purity of substances. So now you have separated substances. How do you know if the substance is pure or impure? A substance is pure in chemistry if it does not have other substances mixed with it. It's not about color now. You have some salts in the laboratory that are colored. But whenever other substances have been mixed, for example, you have salt. What's the composition of salt? Sodium chloride. But now, when you mix sugar with it, that means sugar is made up of carbon, hydrogen, and oxygen. Now, that sugar that has been mixed with salt makes it impure, because salt is supposed to have just sodium and chlorine, but now it has carbon and hydrogen. So whenever there is another substance mixed with your composition, then we call it impure substance. So we have talked about you can separate all of these substances. Now, how do you know if it is pure or impure? Because you cannot really tell physically. So number one criterion we use to check purity is melting point. Number two is boiling point. You can also use their density to tell. Something that has impurity, definitely the density will increase. Then number one, melting point. Whenever you are using melting point, you use melting point for solid. Every pure solid will have a sharp or low range of melting. If I tell you that the melting point of solid A is 50 degrees Celsius, that means when I start heating A up, A will melt at exactly 50 degrees Celsius and probably 49 to 50, just that low range. But if A is impure, it's going to melt between like 40 to 48. The melting point will drop. So impurity reduces melting point. Do you understand that? So whenever a substance is impure, the melting point will drop. When it is pure, it melts at the exact melting point. How about for a liquid? For a liquid, we use boiling point. When a liquid substance is pure, it boils at the exact boiling point. When it is impure, it has a very wide range of boiling, which is above the normal boiling point. For example, if I say liquid substance B has the boiling point of 70 degrees Celsius, if B is pure, it is going to always boil at 70 or between 70 and 71. But if it is impure, it will boil between 71 to probably 80 something. Then that shows that it is impure. So impurity will make the boiling point of a liquid to increase. So impurity increases the boiling point of the liquid and decreases the melting point of a solid. So that is all about matter, and those are the things you need to know about matter. So quickly go through the video, then solve all of the questions that will follow, and leave your answers in the comment section. And please subscribe. I'll be uploading the next video. The next video will be on atomic structure. We're going to go one after the other to cover the entire syllabus. So endeavor to share this video with others that are writing exam so that they can get the benefits of it. I love you, and I'll see you in the next episode. I'll be uploading biology and physics soon, so stay tuned to the channel. I'll see you all around.